In this video, we will be talking about measures of position, percentiles, quartiles, 5-number summary, and box plots with Rguroo. So before we get started, I wanted to show you that I have uploaded all of the data sets that I'll be using in examples. I've uploaded those into Rguroo and I've shared them with you if you are part of my class in Rguroo, and if that's the case, then you will have access to these. So if you don't have access to these, that's okay. You can add the data sets yourself in Rguroo as we go along. So I wanted to show you how to add the data sets for today, for this lecture, into your Rguroo. So if you are in Rguroo, at the very top of the screen, you'll see My Groups. So you'll click on that. It's a drop down, and you are going to click on Show My Groups. If you've not joined my class and you have the code, which would be posted in Blackboard, click Join a Group. So I'm going to click Show My Groups. And then you should see your class. Now I've got several classes listed here, but you should see your class and you're going to click on it. And once you click on it, you're going to see measures of position lecture repository. So you're going to click on that. And then I have 1, 2, 3, 4, 5 data sets that we're using. So you're going to click on each one of those. I have control and then I click and then import selected data sets. If you click each one separate, I mean, you can import each one separately, or you can hit control and then click each one and then import. And once it imports, you'll click OK and then close. And then what will happen is you'll see that all of those data sets will be in your data window pane here. Okay, so just wanted to let you know that up front so that that could make things quicker as we're going through. So back to this measures of position. So measures of position, we're talking about percentiles, quartiles, 5-number summary, box plots, all using Rguroo. We're also going to talk about outliers. First scenario, suppose you score a 155 on the LSAT, which is the Law School Administration Test. You would like to know how well you did relative to everyone else who took the test. If you knew you scored 63% better than others who took the test, that would be a better indication of your success. Therefore, we often want to know where a particular data point falls in the data set. And there are two ways to measure this. One is called percentiles and one is called quartiles. Now, a quartile is a type of percentile. It's a special type of percentile. So let's talk about what a percentile is first, and then we'll move into quartiles. So a percentile, the definition is the pth percentile. So replace the letter P there in pth. That sounds funny, right? With, let's say, 20. So the 20th percentile separates the lowest 20% of the data from the highest 100 minus 20%. So 100 minus 20 would be 80. So just remember, all of the data together is 100%. So the 20th percentile is going to separate the lowest 20% from the highest 80%. Like that. If it had been, say, the lower, if we were doing the 30th percentile, it would separate the lower 30% from the upper 70%. And it's this number right there. Whatever that number is, that would be the specific percentile that we're looking at. So the percentile, in this case, the 30th percentile that I have on the screen, it is the number that is larger than the lowest 30% of the data, but smaller than the highest 70% of the data. I'm going to rewrite this so it kind of matches up with the numbers I have on the right there for the 20th percentile. But that's just kind of like an illustration of it. So you can actually, there are ways to find any percentile you want. We're going to focus specifically on 3 special percentiles. We call them quartiles. They split the data into quarters. So I always think 4 quarters make a dollar. So 4 quarters make a whole. So the first one is Q1, which is quartile 1 is the 25th percentile. And just to kind of show you what it is you're finding, so let's say I have the data here, so it's going to separate the lowest 25% from the upper 75%. That's the Q1 is whatever this number is here. So we call quartile 1 Q1 for short. We also have Q2, which is quartile 2, which is the 50th percentile. So Q2, which is also the median, and it separates the lower 50% from the upper 50%, so half and half. And then finally, we have Q3, which is quartile 3, which is the 75th percentile. So it separates the lowest 75% from the upper 25%. And so that's what we're going to be finding when we find quartiles. And while there are formulas that can be used to find these, we are going to use technology, specifically Rguroo, to find these quartiles. All right, so here are the steps in Rguroo for finding the quartiles. So first you need to upload a data set. All right, and I have shown you how to do that in previous videos. For this particular lesson, again, you can add the data sets I'll be using for the examples by going to my groups and adding those, as I said at the beginning of this video. So once you have your data in your data set uploaded or created, these would be the steps. So we're going to find these quartiles the same way we find the mean, median, and mode and standard deviation that we did in previous videos. So you are going to go to the Analytics tab. You're going to go to the Analytics tab on the left. And in the drop down, you are going to choose Numerical Summary. Numerical Summary. And then once you do, this box here will pop up. All right, so you want to make sure that you choose the data set, the appropriate data set, so either the one you created or maybe one that you've uploaded, and you need to choose the variable that you're interested in finding these quartiles for. In the picture here, I have calories highlighted, and then I click on this arrow to move it to the selected column. And then beneath that, there is a button you can click called Univariate, so make sure you click that, and once you do, this box here will pop up. Okay, and so what you're going to do is you are going to click on Q1, median, and Q3. And then once you do that, you will click the preview button that looks like an eyeball, and then it will pop up in this nice little table, such as the one below that's giving us the Q1, the median, which is the same as Q2 and Q3 for calories of cereal from that set of data. So it's really quick. Again, click on Analytics. In the drop down, click on Numerical Summary. Choose your data set that you're interested in, move the variable you want the statistics for over into the selected column, click Univariate, then choose the statistics you're interested in this case, quartiles, Q1, median, Q3, and then preview. So we're going to do this for the physics exam. So if you need to pause the video and create a data set with these numbers here. So pause the video and you can do that, or you can go to my groups and you can upload the physics exam score data set from the data sets that I've shared with you. Okay, so go ahead and pause that. And if you want to go ahead and try to find the quartiles on your own, you can do that too, and you can come back and then we will go over it. Okay, so if you have completed this already, you just need to go to Analytics once you've either uploaded the data set or created the data set, and click on the drop down that says Analysis and choose Numerical Summaries towards the bottom. A box will pop up. You need to choose your data set. This is the physics exam scores. So I'm clicking on that. And then I'm going to move exam scores, which is my variable, into the column here. If you created your own data set, you would just move whatever you named your variable over to the selected column. Click univariate, and then on the left here, we click Q1, median, Q3, preview. And it looks like we get 57.5 and for the Q1 and 62.5 for median and 74.5 for Q3. So if we click over back to our screen, let's see, 57.5 for Q1. 62.5 for the median or Q2. 74.5 for the third quartile or this is Q3. Just make sure everybody knows that. So yeah, that was quick and easy, right? All right, so let's talk about the 5 number summary. So if we add 2 more numbers to those 3 quartiles, Q1, Q2, Q3, the numbers specifically is the lowest number. We call that the minimum, and the highest number. So I'm going to write that above here, lowest, highest. You have your 5 number summary, and when you write out a 5 number summary, you write it as this list of numbers. Minimum is first, followed by a comma. Q1 is second, followed by a comma. Median is third, followed by a comma. Q3 is next, followed by a comma. Maximum. And you do not have to label them. You just put them in an order separated by commas. All right, so we find it the same way that we found mean, median, mode, range, standard deviations, the Q1, Q2, Q3, all of that, you're going to find the min and max the same way. So we're going to go to Analysis, Numerical Summary, choose our data set, choose our variable, click on Univariate, and click the items that we are interested in. So example 3 says use the calculator, in this case Rguroo, to find the 5 number summary for the physics exam scores from example 2. So I'm just going to go back because I still have this open. I'm going to go back to basics, and I'm going to click on univariate since I have everything already chosen here, and I'm going to add minimum and maximum. I'm going to check those in addition and click the preview, and now we have the 5 number summary, which is 47, 57.5, 62.5, 74.5, and 95. And so let me just show you how I wrote that on the screen there, separated by commas. So again, this is the minimum, this is Q1, this is the median, which is the same as Q2, this is Q3, and this is the max. Now, you don't have to label them like I did here. I'm just trying to show you what each number represented. But you always list them in that order, the way I did, separated by commas. All right, so you guys try the 5 number summary for Miss Guzman's latest statistics exam. The data set, you can either upload it from my groups. The data set's called Miss Guzman's latest statistics exam, or you can create your own data set. So go ahead and pause the video and try to find the 5 number summary on your own, and then unpause when you're finished. Okay, so let's do this. Click Analysis, Numerical Summaries. We're going to choose a new data set. This one is Mrs. Guzman's latest statistics exam scores. And I'm going to move statistics exam scores over to selected, click univariate, and then I'm going to click minimum, Q1, median, Q3, maximum, and preview. And I have the following 5 number summary. I have 49 as the minimum, 76 as Q1, 85 as Q2 or the median, 91.5 as Q3, and 100 as the max. And so there we have another 5 number summary that we can do fairly quickly, especially if you have access to the data already. Like, you can pull that from Rguroo that I've shared with you, and it makes things much easier, I think, to be able to do it that way. Okay, so moving on. Outliers. So let me go back to, there we go. So outliers. Outliers are extreme values. I've mentioned these in previous videos, but now we're really going to focus on them. And they're extreme values that are either much higher or much lower than the rest of the data. And values that are outliers, we consider them not typical to the rest of the data. They're, a lot different. They're not expected. Sometimes these are caused by errors when you're inputting in the data set, but other times they're out of the ordinary observations, which can happen. So before we can learn about how to find an outlier, we need to figure out what interquartile range is, because that is actually used in the outlier formula. So interquartile range is the difference between upper and lower quartiles, which is Q3 and Q1. So IQR, which is interquartile range for short, is just Q3 minus Q1. It's a quick subtraction problem, right? And then to find the outlier boundaries. So basically what these are not the outliers. These are the boundaries. So basically, let me just kind of show you with a line here. Let's say we find the lower boundary and then we find the upper boundary, and this is where they fall on the number line. All right, so anything less than the lower boundary and anything greater than the upper boundary would be considered outliers. Anything in between them is not considered an outlier. Anything lower than the lower boundary and higher than the upper boundary would be considered an outlier. So to find those boundaries, the lower outlier boundary is Q1 minus 1.5 IQR, and the upper outlier boundary is Q3 plus 1.5 IQR. And by the way, we can find IQR by doing Q3 minus Q1, but it's also one of the choices you can check when you are doing the numerical summary in Rguroo. So that's a nice thing. All right, so you want to write those formulas down because we will be using them to help us figure out if there are outliers. So then we have find the outlier boundaries for the following set of data and then decide if there are outliers. If there are outliers, list them. So we've got the numbers 25, 29, 3, 32, 85, 33, 27, and 28. So you can add this data set yourself. And then basically what you're going to want to do is we need to find Q1, Q3, and then if you want to, you can go ahead and find the IQR as well. If you are trying to do this, if you're trying to upload the data set from me, this data set is called, hold on one second. It's called Outlier Example. So that's the one you want to upload from the data sets that I have shared with you on Rguroo. If not, you want to pause the video and enter those data values yourself. Okay, so if you have uploaded the data from me, or if you've put it in yourself, we want to go ahead and go to Analytics, go to Numerical Summaries, and then choose the Outlier Example data set, and then move the one variable over, univariate is chosen, and we want Q1, Q3. You don't necessarily need the median here. You just need Q1 and Q3 to be able to find the IQR, and both of these are used in the formulas. But you can also click IQR because that's on here, and we can get those numbers. So I'm going to write down what each one is, and you should too. So Q1 is 26, Q3 is 32.5, and IQR is 6.5. And so remember, I just want to show you how they got this. IQR is Q3, which is 32.5, minus Q1, which is 26, and that would be 6.5 when you do the subtraction. And so I actually need to go back here to this screen so you can see it. So 32.5 minus 26 is 6.5, which is the IQR. So I've written those down. Hopefully you've written those down too. And so now let's do the lower boundary formula. The lower boundary is Q1 minus 1.5 times, oops, let me make that look like a 5, times the IQR. So if I fill those in, that's Q1, which is 26, minus 1.5 times IQR of 6.5. And we get 16.25. And so that means that anything lower than 16.25 is an outlier. And so are there any numbers lower than 16.25? It looks like 3. So I believe 3 would be an outlier because it's lower than the lower boundary. Now, the upper boundary is Q3 plus 1.5 times the IQR. Okay, sorry about that phone ringing in the background, but we have Q3 plus 1.5 times IQR, which would be 32.5 plus 1.5 times IQR, which is 6.5, and if we calculate that, we get 42.25. So again, anything higher than 42.25 is an outlier. So are there any numbers bigger than 42.25? It looks like 85 would be an outlier. So the outliers are 3 and 85. So you always want to show your proof that numbers are outliers. You can't just guess. I mean, I could have looked at it and thought, I think 3 and 85, I think they are, 3 is definitely a lot lower. 85 is definitely a lot higher than the rest of the data, but there's no proof that they really are outliers unless you find these boundaries first. So if you're looking for outliers, always show your work by finding the boundaries first and then use that to help you identify the outliers. All right, so that brings us to box plots. So a box plot is a graphical representation of the 5-number summary. And if you remember the 5-number summary, those quartiles break things up into quarters. So you can see where the data is clustered together and also where it's spread out. And there are 2 types of box plots. A basic box plot, like the one that I have here on the screen, and there's also a modified box plot that shows outliers. So let's look at the basic box plot. There's usually, or there should be, a number line underneath your box plot so you can see where each of these numbers fall, right? So you want to always make sure that you have that. And then basically from the minimum to Q1, so basically from the minimum to Q1, you draw a horizontal line, right? And then you will draw 3 vertical lines, one at Q1, one at the median, one at Q3, and you'll use that to form a box. And then you will draw a horizontal line from Q3 to the max. All right, and so each one of those sections is 25%. So you can see that whatever the median is, it is bigger than 25 and 25, so bigger than the lower 50% of the data and smaller than the upper 50%. You can also see that in this particular one, a lot of the data seems to be concentrated in this small area here. 50% of the data is from here to here, which is not very spread out at all, whereas this seems very spread out. That's your basic box plot. We also have a modified box plot. Also, with modified box plots, you will have a number line underneath, right? And so this one is similar, okay? The box is still made up of Q1, the median, and Q3. The difference, though, is that this and this is not necessarily the min and max. This is the lowest non-outlier. So if you have an outlier, then don't treat that as the minimum. If you have a minimum, if your minimum is an outlier, don't treat it as where the whisker goes to. Draw the whisker to the smallest number in the data set that is not an outlier. And the same thing here on the right. This is the highest number in the data set that is a non-outlier. And then what you do is you asterisk or you star any outliers. And that's what a modified box plot is. Rguroo will do both for you. Okay, Rguroo will do both for you. You can identify outliers with stars, with asterisks, with X's. It's up to you. Rguroo, it identifies them. You'll be able to see them when we graph one in a minute. All right, so to create a box plot, it is a plot. So in the Plots tab in Rguroo, you are going to, in the drop-down, choose Boxplot. And then just like with everything else, you need to choose a data set. All right, choose your data set. And then move the numerical variable that you're interested in graphing, move that over. So you can see in the screenshot here, I've moved calories over into the selected. If you want to graph it by factor, if you want to focus on like any specific factor, you can move that over as well. But if you just want a basic one, don't worry about that part. I like to check horizontal because I like to have a horizontal box plot like the ones here and here. But I will tell you that the default is vertical. So if you don't click horizontal, it's going to do a vertical box plot, which is the same thing. It's just turning this vertical. All right, and the other thing that I like to do is I like to click Show Mean. This is not necessary, but it helps you to compare the mean and the median. All right, so then you can adjust your titles and labels as necessary, and then click Preview, and then you'll have a nice little box plot. So creating them with Rguroo. So this would be, I just want to show you that when you create it in Rguroo, it will identify the mean with a diamond. So for this one, you can see that the mean is greater than the median. And if you'll remember from previous lectures, that means that this is most likely skewed to the right. All right, so I did want to show you that Rguroo will do circles for the outliers. I do want to show you like what you need to do if you were to let me just create this one for you. Let's just do this one that I have graphed here. Let me just do this with you fairly quickly. All right. So hopefully I'm still logged in. I'm going to go to Plots, Create Plot, and then I'm going to choose a box plot. And then I believe in the screenshots I chose Serial, so I'm going to do that again. Serial, and then I move calories over. And then I click horizontal and Show Mean and Preview, and there you have it. So you can see this is calories. Here's the number line beneath. You can see you can see where the minimum and the max are. The Q1, the median is the line that is between Q1 and Q3, the line that's in the middle of the box, and the diamond represents the mean. I do want to say I don't think there are any outliers in the calorie data, but the default is to show outliers. So the default is going to show you a modified box plot. And so if you don't want that, where it's drawing circles to show you the outliers, if you don't want that, then this is what you do. You're going to click on details, which is next to the basics box in Rguroo where you've done your box plot. You're going to click on details, and then you're going to choose the median, whisker, staple, and outlier tab. And then once you're there, you're going to click outlier tab. So you can see here, you're going to click on box, median, whisker, staple, outlier. You're going to expand that and then click on the outlier tab. And if you don't want outliers to be graphed, if you just want them to be treated like a regular part of the data set, not as an outlier, you just click extend. And then it will extend the whiskers out to the lowest and the highest, and it will not identify the outliers. And then you would just click preview. So let's real quick, let's go there. Let's just go to details, and then you would hit box, median, whisker, click on outlier, and you would click extend. Now it doesn't really change anything here because there were no outliers in the serial data to begin with. So now we're going to do another data set. We're going to use this data set for the number of pages and 40 books on the shelf. Again, you can pause the video and you can create this data set in your Rguroo, or you can upload it from My Groups in Rguroo. This data set, let's see what this one is called. This data set is called Total Pages for each of the books on the shelf. That's what this data set is called if you're uploading it from My Groups. All right, so why don't you pause the video and either upload that data set, create that data set, and then try to do a regular box plot, not a modified. And then unpause it, and we will go through the steps on how to do it. All right, if we are creating this plot, we're going to click plots. In the drop down, choose box plots. We're going to choose our data set, which is the total pages for each of the books on a shelf. I'm going to move my one and only variable over into selected, and then I want to make it horizontal, and then I like showing the mean. And then if I click here, I can see the box plot. And so there you have it. Very nice. All right. So let's do one where we're comparing two groups. So it says test scores for statistics class held during the day are the following, and then test scores for statistics class held during the evening are blank. And we're going to create a side-by-side comparison of these two groups. So let me just show you how to do that real quick. This data set is called, let me go down to the bottom here. It's called Statistics Test Scores, and then in parentheses I have day and evening. All right, so again, you're going to go to create a box plot. So plots, drop down, choose box plot. And then in the data set, we're going to choose Statistics Test Scores day and evening. And then I'm going to move both of the numerical variables over, both day scores and evening scores. I'm going to move them over. And then I'm going to click horizontal, and I'm going to click show mean, and then I'm going to do the comparison. And look, you can see, oh, actually, let me go back to details because this is showing the outliers. So I'm going to click on box, median, whisker. and staple under details, and then click on the outlier tab and click extend. And then I'm going to hit preview again, and it's going to take the outliers out. Okay, so you can see this comparison. You can try to see who did better. I personally think that the evening scores are better, because if you look from here, this is Q1 up to the max, that's 25, 25, 25. That's 75% of the class scored well above 50% of the daytime class. And I know this is 50% from the median to the left. The left side of the box is 25%, and then this whisker is 25%. So I think whereas you did have some low scores, the majority of the scores, 75% of them were actually pretty high. So I personally think the evening scores did better, but that would be how you would compare two at one time, which is pretty cool way to do that. And then, all right, so this one we're going to do a box plot with outliers. Box plot with outliers for the evening data. So I'm going to go back to, I'm just going to do another one just so you don't get confused. Create box plot. And then select your data set, which is day and evening stat test scores. And then I'm only going to move evening tests over this time. And then I'm going to click horizontal. And I just like to show the mean. Again, you don't have to do that. And then where it says details at the top, I'm going to click on box, median, whisker, staple, and outlier. And then click on the outlier tab and make sure it says show. So if you don't want them, click extend. If you want it to show them, click show. And then you can choose different characters for how you want them to be displayed. But here we go. You can see I have these little circles. You can really see that the majority of the class scored above a 60, almost the entire class. And then you have these two extremes. A person scored probably around a 45 and someone scored below a 30. And those were not consistent with everybody else. They were not typical. So there could be some reasons that happened. Maybe the lowest score was somebody who never comes to class, or maybe the person that made a 45 was sick the night before and didn't have a chance to really study. So there you have it. All right, so one more thing. I'm comparing, this is the last slide, comparing symmetrical and skewed data and what they look like in as a histogram versus what they look like in a box plot. So skewed right, if you will remember, skewed right is when the lower bars are on the right. Okay, so it is also where the mean is greater than the median. But I want you to look, if you were to draw a line straight down the median and you were to compare the left side to the length of the right side, which side is longer? The right side is longer, from the median all the way to the maximum. So because that's longer, this is skewed right. Whereas if we draw this line straight down the median here, we have the lower bars on the left, which means it's skewed left. But in this case, the box plot, the longer side is the left side. So if you compare the left side to the right side, the left side of the median is definitely longer, so this would just be skewed left. And then if you draw a line through the center, and they're approximately equal on both sides, they is basically symmetrical, or approximately symmetrical, and it's not really skewed. I just want to go ahead and write when they're skewed left. When they're skewed left, the mean is less than the median. That's why it's helpful when we do these to, let me go back to the Rguroo screen. But okay, so check this one out here. Here's the median right here. You can see my arrow. The mean, which is this diamond, is less than that. And then, so I would think this is skewed left. Also, if you go from this median all the way to the end, this side is longer, the left side is longer than the right side, so it's definitely skewed left. So I think that diamond can really help you if you're trying to figure out the shape, the distribution, and that's whether it's skewed left, skewed right, or symmetrical. And that is it, folks. That is it for measures of position. If you have questions, please let me know. Have a great one.